For decades, clinical and public consensus has categorized creatine almost exclusively as an osmolytic sports supplement, a compound used to drive water into skeletal muscle and increase physical output. But recent neurochemical data reveals a different reality. Creatine functions as a central neurotransmitter, stored in and released directly from synaptic vesicles upon neuronal stimulation. To maintain baseline cognitive function, the brain endogenously synthesizes its own supply of this compound. We also know that exogenous creatine consumed through diet or supplementation, can actively cross the blood-brain barrier. The blood-brain barrier is a highly selective semi-permeable border of endothelial cells that prevents solutes in the circulating blood from non-selectively crossing into the extracellular fluid of the central nervous system. Once across, this creatine replenishes the brain's internal stores. During states of high metabolic demand, like severe sleep deprivation or trauma, local endogenous synthesis simply cannot keep up with the brain's rapid depletion of its phosphocreatine pool. Clinical evidence defines creatine as a conditionally essential neuroenergetic buffer that rescues cellular energy during acute stress. A 2024 meta-analysis encompassing 16 randomized controlled trials and 492 participants provides the baseline for understanding this effect. The selected trials demonstrated a low to moderate risk of bias and an absence of publication bias, confirming the rigor of the underlying data. The data dispels the myth of a global cognitive boost. The aggregate results show zero significant improvement in overall executive function. This chart shows standardized mean differences for specific cognitive domains. First, data shows significant improvement in short-term memory, landing at an SMD of 0.31. Second, the data reveals a sharp improvement in processing speed time, showing a stronger effect size of -0.51. These functional improvements are corroborated by physical evidence. H1 NMR spectroscopy, a magnetic resonance technique used to determine the structure and concentration of organic compounds, confirms that oral supplementation physically increases brain creatine content by 3 to 10%. The aggregate clinical data proves that oral creatine physically alters the brain to provide targeted enhancements to memory and processing speed, rather than a generalized boost to intelligence. The brain is a highly energy-hungry organ. Rapid neuronal firing quickly depletes cellular energy reserves. This diagram shows the required energy transaction of a cell, ATP molecules losing a phosphate to become ADP during intense cognitive tasks. Phosphocreatine instantly intervenes, donating its phosphate to rescue the ADP and regenerate it back into ATP. This phosphocreatine ATP shuttle operates significantly faster than standard energy production pathways like oxidative phosphorylation or glycolysis. This rapid energy rescue is highly applicable to trauma models, specifically traumatic brain injury and concussions. Following physical trauma, a glutamate cascade triggers a deadly influx of intracellular calcium, leading directly to neuronal cell death. Creatine mitigates this excitotoxicity. By maintaining mitochondrial integrity, it reduces cortical damage by up to 36% in mammalian models. Optimized creatine levels also directly support the synthesis of crucial neurotransmitters like acetylcholine, which aids in synaptic plasticity. Creatine functions as a biological safety net. It steps in to prevent cellular death and cognitive failure when standard metabolic energy production is overwhelmed. We can identify exactly who benefits from this supplementation using the deficit principle, the rule that creatine's cognitive efficacy relies entirely on correcting a pre-existing bioenergetic deficit. This graph compares baseline brain creatine and post-supplementation memory improvements between omnivores and vegetarians. Lacking meat, vegetarians have lower baseline stores. Starting with this deficit, trials show they experience significantly larger memory spikes from supplementation compared to meat eaters. The second vulnerable population is the sleep-deprived. 24 hours of sleep deprivation severely degrades brain bioenergetics and baseline executive function. Acute creatine supplementation directly attenuates this loss. It stabilizes complex central executive function, mood, and balance under heavy sleep debt. The third cohort includes aging populations and traumatic brain injury patients. Aging naturally alters brain metabolism, making the older brain much more reliant on the phosphocreatine buffer system to maintain normal function. Creatine acts as a targeted rescue agent. If a population has lower brain creatine or is under high neurometabolic stress, they are the primary beneficiaries of supplementation. To practically apply this data, we must look at the specific protocols required to successfully navigate the blood-brain barrier. The validated form of the compound is strictly creatine monohydrate. Alternative chemical structures lack the rigorous validation seen across the 16 randomized controlled trials. The blood-brain barrier restricts molecule flow. It has limited creatine permeability because surrounding astrocytes lack the essential SLC6A8 transporter, the protein responsible for moving creatine across cell membranes. Overcoming this resistance requires higher clinical doses, from 5 to 20 grams per day. Compared to skeletal muscle, the brain takes significantly longer to reach saturation. Clinical application relies on a dual protocol, a 7-day loading phase of 20 grams per day to address acute stress, or a steady 4-week maintenance phase of 5 grams per day for a long-term baseline shift. Effective cognitive protocols require exact dosing and patience. Treating the brain like a bicep fails due to the strict limitations of the blood-brain barrier. This brings us to a pervasive myth, the idea that creatine is a universal nootropic or a pill that will make everyone smarter. This chart illustrates the reality for healthy, unstressed young omnivores taking the supplement. Systematic reviews show that performance on cognitive tasks remains largely unchanged in this healthy cohort. Creatine is not a central nervous system stimulant. It cannot force a brain to perform beyond its biological maximum. If the brain's energy pools are already saturated and unstressed, adding creatine yields zero cognitive return. Its true clinical value lies entirely in its role as a highly effective biological safety net.